So I thought I would do a pretty interesting experiment today. I'm going to be replacing the H60 that's in my computer with a Hyper 212 Evo. The reason why I'm doing this is because I've had that water cooler for about a couple years and it's gotten a little bit unreliable. Sometimes the pump freezes and I have to shut down my computer because it reaches maximum temperature, and it's not a great thing. Now, I've already run the loads for the H60. So we have 42 degrees no load and 57 degrees full load for at 100% fan for the H60. Now I haven't installed the Hyper 212 Plus yet, or Hyper 212 Evo yet, so we're going to see how that performs. But I have a couple of speculations about water coolers versus air coolers, and a lot of people are like, wow, water cooling is really cool, it's really great, it performs really well, and all that other things. But I think for the risk that you get out of water coolers, you're better off just getting this $30 tower heatsink like this. And why do I say that? Well, there's a lot of components that can go wrong in water cooling. You can have the pump fail, you can spring a leak, coolant can evaporate from the pipes. It's just a whole bunch of mess that really, for what we're trying to accomplish here, is not necessary. So, and I'm pretty sure that a low grade, or well, this is a mid grade air cooler versus a low grade water cooler, this will perform much better. And there's a couple of reasons for that. First off, the way that water coolers work is that they use the thermal capacity of water to move heat around. And that's great because water has the highest thermal capacity of any material, which means that it takes the most amount of energy before it will start raising in temperature. Now, the whole reason why you put in water is because you have to move it. You're trying to move heat away from a source and cool it somewhere else, is really what you're doing. You're transferring the heat to the water, and then you're going to pump the water somewhere to cool it down. And that's what the radiator is for. Now, the radiator in that is pretty small, but and therefore the transient heat up time is going to be much longer than an air cooler. In other words, it's going to reach its maximum temperature much later than an air cooler will, but the surface area of that is pretty much like half of this. Now, the other thing that's interesting is that the whole reason why we're doing that is so that we can transfer heat and cool it somewhere else. Well, that's what a heat pipe does. It does the same thing, and heat pipes are really very, very good. Basically, if I put a load here, this whole heat pipe will be pretty much the same temperature all the way up and down. They're very, very good conductors. So I have twice the area, give or take, twice the area on this, therefore this should perform much better than that. I've looked at a couple of performance charts, and most of the time they don't show the lower grade water coolers, and like usually they start off with like an H80 or something like that, which is about the same size as this, and they perform pretty much on par. So I'm pretty sure, well, I know that this should perform much better than that. And the other thing is that I don't have to worry about the maintenance. There is none. Fan will die after about 40,000 hours, or at least that's what's said on the box here. These are hydrodynamic bearings, so yeah, long leaf sleeve bearings. So in other words, once the lubricant in the bearing dries up, the bearing will fail, and I'll have to replace the fan. But that's another component that's the same thing that I have to do on this, is that I'll have to replace the fan on that. And I haven't reached 40,000 hours, so I haven't had to worry about it. But the pump probably has a much lower life expectancy, especially since it's in contact with water. It's got a lot more stresses on it because we're moving water, we're moving mass. It's going to be less energy efficient than using a passive system like this. So I think water coolers are a fad. The thermal output of CPUs has not changed in the last 8 years or so, seems like most CPU manufacturers are going for 130 watt power dissipation, which is good because we don't want to increase power dissipation because that means our efficiency goes down. So you're wondering, well, how are we getting more performance out of a chip without increasing the amount of power that the chip gets? And really it comes down to the minimum feature size. This CPU has a 32 nanometer feature size, which means that the gate length, the average gate length of each transistor in there is 32 nanometers long. Current Intel CPUs have 22 nanometer length. So you can say, well, the current Intel CPUs on average should be much more powerful than the AMD CPUs because they're built on a much smaller process. There's less parasitic capacitance, chips run faster, they run cooler, they don't use as much energy. And we're right. That's completely true. And it's only going to get smaller. Current projections are that 7 nanometers are the smallest. I'm pretty sure the new AMD CPUs are going to be around 14 nanometer. Most smartphones are 20 nanometer. That's how you're getting really high performance out of a small chip without using much power, is that they're very, very small and the memory is right on top of them. So I have a feeling, well, I know that they're not going to increase the power, and the risks for water is a little high, and you're better off just with a $30 heatsink versus a $60 or more heatsink. This should do everything that you need to do. If you don't like the aesthetic of it, well, you can always get, there's so many on the market that you can get whatever suits your fancy, but this one should be the standard that we look at. So I'll replace it and we'll see what the numbers come up with and compare it with the H60. Okay, so we finished installing the Hyper 212 Evo. It took about an hour because the cutout on the Fractal Design R4 isn't quite large enough for AMD brackets. It hides underneath the cutout a little bit, so you have to pull everything out and put it back in. I'm alright with that. So it took about an hour to do. Now, there are results that are quite compelling for this. With both fans being at 100% for both tests in the same room temperature, we went from being 42 degrees C on the H60 to 29 degrees on the Hyper 212 Evo. And at full load, 57 versus 45. So it's a good 12 degrees difference. And my thought on all-in-one liquid coolers is don't bother with them. I know that they look cool. They perform okay if you get ones that are double radiators or 140 millimeter or thicker ones. They perform about the same as the Hyper 212 Evo. It performs about the same. So why would you spend more money on it when a regular tower heatsink with heat pipes does the job beautifully? Now, with that being said, the H60 is 2.5 years old at this point. So I didn't write down how well the performance was when you first get it. Or I probably did the tests, I just don't remember. It's been a while, 2 years. But the thing is that the surface area is what matters, and the only reason why you want to do water cooling is if you want to move more coolant to another area of the case. And since the H60 is a single radiator, it doesn't make any difference. And the other thing too is you just don't need it. It's overcomplicated. You got pumps, you got wiring, and you got water with propylene glycol to making sure that it doesn't freeze if you're shipping it. Why? I mean, you're better off keeping this system a lot simpler. There's less stuff to go wrong. It performs about the same, and the noise isn't any different. Actually, what most people, well, what you mostly hear from computers now that they're a lot higher power consumption is coil whine from the switching of the power circuitry on the GPU and wherever else on the board. So fan noise is not that much. I don't know if you can hear it in the video, but it's less than 20 dB, so it's not a big deal. If you have an air conditioner, you won't hear it. The performance and the simplicity of it is what sells it. As far as the bigger air coolers go, like the Noctua ones and whatever you want, there's a trade-off. They are heavy, they're expensive, and you get marginally more performance, like maybe 6 or 7 degrees. Again, with larger surface area, you get better performance. So at lower fan speeds, you don't have to move as much air over it. Some other ones, they have a little bit of a lip on the edge of the fins to create more turbulence, so that the air mixes and you don't get a laminar area where the heat transfer is not as good. But it's all about personal preference. I would stick with the some type of tower heatsink, single, double. It's the best bang for the buck. There's plenty of them for $50. This one's $30, and it's beating out a $70 or so water cooler. Water cooling doesn't start to pay off unless you are spending about $100 on a double radiator. It really doesn't make that much of a difference. And the other thing too that's interesting is that most people don't overclock. So why do you need the cooling? You know, you don't want to run the system and overclock all the time anyway, because you're putting a lot more stress on the CPU. And the other thing too, this CPU is 4 years old. Well, yeah, I guess it came out in 2011, so about 4 years old since its launch. It's an 8-core or 4-core, depending on how you want to look at it. And in most games today, I don't get more than 50% usage. The things that change are the GPUs, and the reason why a GPU from about 3 or 4 years ago doesn't perform as well as the GPU today is because we're leaning towards much higher resolution. So the memory that comes with it is what really was the big revolution. We went from having 1.5 gigs to now this card has 6 gigs on it, and that produces a lot. But as far as frame rates go for games that have similar size, you get about maybe 20 more frames per second. So you're much better off getting a decent CPU and a motherboard that you like. You have to get a motherboard that has all your features. I would spend a lot more money on the motherboard than you would on the CPU. Well, relative, on the CPU. And that's it. I mean, it's really easy and simple to have an air cooler versus having a water cooler that will have its hiccups and not perform well as you thought it was going to when you bought it. So, like I said, I recommend just having a regular air cooler. Any tower heatsink should do fine, but as far as price to performance ratio, a $30 heatsink from Cooler Master does a fantastic job. It's quiet, and even on the silent mode right now, we're at 28 degrees C, which is much lower than the H60 was. So yeah, it's all hype. And that's it. See ya.